Welcome to another NYNJPA weather education video. Today we're going to talk about models and when to use them and which models you really should be using for particular time periods. We're going to use the Penn State EWOL website, which is really a great website to use. Let me scroll down here and show you what the address is. meteo.psu.edu. Now, in all fairness, I didn't go to Penn State, but still, when they do a great job with the website, you gotta give them props. And they have done an amazing job with this website. The reason why, well, you can pretty much get almost every model guidance you could think of on this website and use it appropriately. Now, first things first, there are certain models that you can use for particular time periods. For example, when there is a snowstorm that could potentially be forecasted, let's say about 6 days out, or even 4 days out, the model you do not want to use is the NAM model guidance. Why? Well, the NAM model guidance goes out to 66 hours, which gets you almost to 4 days. And while it does go out that far, that doesn't mean you should use the model out that far. And the reason why is because the further you get out in the time periods here on any model guidance, the less resolution you have, which means basically you're kind of stretching the capabilities of the model to the breaking point. So if you base a forecast based on a solution 84 hours out on the NAM model guidance, you're basically leaving yourself open for trouble because you're at the farthest extent of the model guidance, and you start to lose the capability of the model guidance to forecast correctly. Even more importantly, let's say there's an error at the start of the model. Let's say it's 6 hours out. Well, the further you go out in time with that model, the worse the error gets. It becomes worse and worse because it feeds back on itself. So, two aspects that you want to consider. One, how well does the model perform 6 to 12 hours out? And two, where are you forecasting? If you're forecasting within 42 hours, the NAM model guidance is an excellent model to use. If you're forecasting 3 days out, 66 hours, again, excellent model to use. There are models that are better, which I'm going to show you, but you could still use it. But when you start to get out to 72, 78, and 84 hours, that's when it starts to get a little bit iffy, especially with the details. So let's go back here. Now, what we should use when we're forecasting about 7 to 10 days out is typically what's called global models. Global models include the GFS, the Canadian model guidance, CMC, and the European model guidance. You can also use to some extent the UK Met guidance, and of course your favorite ensemble model guidance. Now let's go to the European model guidance, which is right here. This model guidance, especially when you go out to 240 hours, is an excellent model guidance to use. Okay, it does a wonderful job with forecasting the synoptic, large-scale developments in the atmosphere. It handles the 500 millibar pattern very well. It has the correct what's called resolution to handle this type of forecast. Now again, you don't want to trust a model guidance verbatim at 240 or 216 hours, but at least you get the idea of where the pattern is going. Conversely, you do not want to use the European model guidance when you're forecasting a severe thunderstorm event, or at least getting down to the specifics. You want to use what's called a mesoscale model. So there's different models for different levels of the atmosphere and different forecasting. Synoptic models, global models, models where you're forecasting 3 days out, 5 days out, 7 days out, and even, 10 days out. That's when you want to use the European model guidance, the GFS model guidance, and the Canadian model guidance. See the GFS right here. And with the GFS model guidance, this is a perfect example of where global model guidance probably should not be used. Global model guidance, like the European model guidance, only goes out to 240 hours for a reason. Because that's at that point, that's at the limit of reasonable capability in the model guidance to handle resolution and all sorts of finer details in the 500 millibar pattern. Once you get beyond this point, notice this. It starts to lose what's called resolution and capability of forecasting accurately a evolving 500 millibar pattern. Now, it could be correct at 300 hours. We're talking about the GFS. It could be correct at 384 hours, but I wouldn't bet on it. Okay, now, like I said, it could be absolutely correct here that we end up with this very cold weather pattern and we have snow in the northeast and everyone gets excited right around Thanksgiving. But again, I wouldn't go around advertising this solution because there's a lot of what's called volatility. There's a lot of uncertainty. And when you get out this far, small errors here become big errors here. Okay? So clearly, there are some uses you can use with this type of model guidance, especially as far out. You can get general ideas of where the pattern is going, but don't go with the details. That's not what this model guidance is for. But what you can use this model guidance for, and you can kind of see it in the way that it handles the different 500 millibar patterns here, the different disturbances. Notice that it has a lot greater detail, finer detail here with the 500 millibar pattern, up to about 180 hours. Then it starts to lose its capability as you head further out to roughly, notice that it's backing off on its, I guess you could call it description or details, all right, at 500 millibars and also at the surface. Okay, it's starting to lose its resolution here. You can see that very clearly here as it starts to back off on some of its finer details in the pattern. But what about when you're forecasting a severe thunderstorm event? Great question. That's when you want to use model guidance like the NAM model guidance. Okay, now this is just one model guidance that you can use. Okay, now this model guidance gives you what's called mesoscale data, finer details in mesoscale data. This is where the little things start to add up, like the thermal gradient over the ocean, or perhaps the thermal gradient right along the coastal plain, perhaps where winds start to converge due to topographical influences, or perhaps where a mid-level disturbance is able to interact with a storm. It is this type of model guidance where you forecast for events like, let's say, lake effect snow, or for a severe thunderstorm event. You kind of get the finer details of when those thunderstorms will move through. You don't want to use a global model guidance because it's too big, it's too far out, it's too expansive, so it doesn't have the capability of picking up those details. Another model guidance you can use, I'm going to show you how to get to it. Let's see, forecasting, let's see, models. Okay, this is a perfect one to use. Go to twisterdata.com. There we go. Now I'm going to show you the website here. Twisterdata.com. This website is another great website to use, and you can use what's called the WRAP model guidance. I use this quite a bit on Twitter to discuss severe weather events. It only goes out to 18 hours. Again, as you head towards the end of the model, you really don't want to rely on a lot of great details at that stretch. But this model guidance does give you hour by hour updates and evolution of mesoscale events. This is the model you really want to use in the middle of a storm. Let's say a severe thunderstorm event's approaching, or let's say you're trying to find out snow banding within a storm, whether or not you're going to get convective banding setting up in a snowstorm. Those are mesoscale events. This is a perfect model to use. You have a wide variety of information here from 500 millibars. If you know what you're looking for in that event, I mean, this is an excellent model to break down the levels of the atmosphere, the different focuses, wind, dew points, heights. But all of that's great, but I have an even cooler aspect you can use here. You can also get a vertical view of the atmosphere via what's called a skewed T-chart. Now, remember we were talking about that? Now look what you can do with this website, and this is absolutely outstanding. You can move this cursor here, say Central New Jersey. You can plot your new sounding, and sometimes it takes. There we go. Okay, so now we have our new sounding, and we could get a vertical view of the atmosphere over, let's say, around Trenton. Setup of the atmosphere with a model that is meant to pick up mesoscale events. So with this model, guys, you could use a SKU-T forecast to pick up what's happening in the atmosphere, whether or not it's viable for convective snowfall or thunderstorms or severe weather, where the wind gusts are, whether these winds will get mixed down to the lower portions of the atmosphere. But this is a model, guys, that you want to use. Now let me show you one that you don't want to use, the GFS. Now again, the GFS is an excellent model guidance for the mid-range. Okay, the European beats the heck out of it almost every time, but still it's improving. You know, it's got its upgrade. It still has its issues, but it's getting better if you know how to use it properly. At any rate, this is a model guidance, the same time period, but it looks a little bit different. It doesn't have the finer details that the RAP model guidance showed for that same time period, and it isn't able to break down hour by hour analysis, and it only updates every 8 hours. Now, let me get to, 6 hours. Let me get to one very important point and go back to the Penn State UL website. There is, in the American model suites, a unique time period in the model guides called 06Z and 18Z. I cannot stress enough how I do not ever base a forecast on 06Z or 18Z model guides because it's missing a lot of key components in forecasting for mesoscale or synoptic events. I would advise to stay away from the small guidance unless you're using it to try to see whether to pick up trends. Every so often, if there's an error with 12Z model guidance or 0Z model guidance, the 06Z and 18Z model guidance has that correction built into it. Otherwise, I would stay clear of it. I certainly wouldn't trust what's being put out by the 18Z or 06Z model guidance. The 18Z in particular has been known to be one of the worst model guidance out there. Even for the GFS, it's the worst. So I would not use it. Mesoscale model guidance, going back to that. Short range ensemble, this is another great source of information to pick up. It's not as fine as the RAP model guidance because the RAP model guidance updates every hour. But still, it's a great model guidance to use to kind of get an idea. It takes an average of the model guidance that you have from this suite, and then you can kind of get an idea where the pattern overall is moving over the next, let's say, 66 hours. Again, this is another model guidance where you can use up to 66 hours, but then thereafter I wouldn't trust it all that much. You notice how it completely changes the way that it forecasts the event here in the plains, going from nothing dry to starting to evolve into a precipitation event over the northern plains. Could be right, but the details probably aren't as trustworthy as you would like. So that is the breakdown of model guidance and how to use them, as far as when to use them. Again, just to go over everything one more time. During short time periods, what you want to use is mesoscale models. The NAM model guidance, for example, one model in particular called the HWF is an excellent model guidance to use. We got the NMM right here and the ARW. Both of these model guidance here are excellent model guidance to use for forecasting for mesoscale events. The other model guidance is, of course, the RAP model guidance, which you can get at twisterdata.com very easily. It's an excellent source of data, especially during mesoscale events. You just click it right here, and you get all the data you need. And as we head into the winter months, this will be a key aspect to take a look at during and just ahead of major winter storms. And then as you head out further, when you look at the forecast for day 3 on through day 7, The number one model I would suggest is the European model guidance. Thereafter, the Canadian model guidance. Then you got the GFS model guidance. I would use that in those orders. You could also use the UK Met to see whether it's backed up by the European model guidance. And you can use the Canadian model guidance also to see where the models are evolving to. But remember, the Canadian model guidance tends to be a bit over amplified, so I wouldn't always trust it. If you're looking to see a forecast for a big storm, you could always trust the Canadian to produce some outlandish forecast. At one time I saw for a winter storm, it pretty much phased every disturbance in North America together. So it tends to over amplify the storms just a bit. So again, the number one model guidance you probably want to use is the European model guidance for days 3 on through 7, even out to 10. The GFS model guidance has its moments, but I would trust it from days, let's say 5 through 7, and then around day 3, it does an amazing job. It has excellent accuracy at day 3. Not so much at 4, 5, and 6. So that is your video discussion for this week on how to use the models and when to use them. Of course, I'll have another video coming up next week. Thank you again for joining us for another educational video. As always, stay safe out there. And I'm your meteorologist, Stephen DiMartino.